Okay, so this is one of the O-level question where they ask about where they phrase this basic rate of change. So I'm not going to go through part A. So I'm going to presume part A you are able to get it. So I will be getting a 4 minus 9 over this. Okay, so most people will get stuck in part B. Most people will get stuck in part B. So I'm going to teach you two approach for part B. And after these two approach, you can give it a try for question 6, which is the same idea. Okay, so if you look at this question, okay, let's try to break down the question first. So for example, this, if you look at this is indicating dy dt. If represent equal 3 times, that means it's 3 multiplied. Okay, what is the 3 multiplied to? It's 3 times the rate of change of x. So which means it's dx dt. So the question just gave you this piece of information. Okay, so how are you going to use this piece of information to find the value of x? Okay, so there are two approaches. So first of all, please understand that this is what they are giving you. Okay, so method 1, you can do it this way. So I will look at it as this is a multiplication. It is a multiplication to a fraction. So to me, it looks like this is a multiplication of a fraction. So I'm going to work backwards. Then that means, right, I'm going to throw it backwards. So when I throw it backwards, essentially it is a divide. So I see it as a fraction. Sorry, I should be writing a dx dt. So from a multiplication here, I divide over. So to me, I see it as a multiple division of a fraction. So in your basic algebra, when you divide a fraction, you can do a reciprocal. So I'm doing a reciprocal. So after the reciprocal, sorry, I read something wrongly. This part should be a t. Okay, so this is my, okay, I transfer wrongly. So this should be the same. So I'm like dividing the dx dt over. So after I try doing this, my t is cancelled. My dt is cancelled. So I end up dy dx equal to 3. That means essentially I use the dy dx and then you continue. Continue to find your x. So that can be method 1. Okay, method 2 will look something like this. Okay, personally, I don't do method 2 a lot of time, but it's a proper method. So remember just now, this one was a generic, it is a generic formula, right? So this was a generic rate of change formula. So some people will use this generic rate of change formula. So how do they use it? They substitute in. So dy dt is equivalent to this. So they substitute in. And when that is being substituted in, you realize that you can cancel. You can cancel the dx dt. So this is being cancelled. And I'm left with a dy dx equal to 3. So you still perform the same thing. Take your dy dx, solve it like algebra. So I think method 2 might look easier for some of you. Some of you might like method 1. Maybe for some of you, you didn't realize that, that means you didn't realize that dx dt is a fraction. It's essentially like a fraction, even though it looks like it is a notation. So I perform that kind, or you can use the generic standard formula for rate of change. You see whether you can use the idea, whichever method you like, and try it on practice question 6.